welcome. In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to create our own web browser by adding support for tables. This was our application at the end of the last video. We have the beginnings of a web browser. We have on screen an index page, and on there we have a number of images. Each image links to a separate page. So we have achieved the ability to click on an image and use it as a hyperlink. We also have standard text hyperlinks linking us to another page. The purpose of the World Wide Web was to allow it to display information to users and to hyperlink to other documents. Some of the data on these pages would be in tabular format, and HTML used the table tag to control this information. So that's what we're going to work on today. We're going to extend our browser to support table tags. So before we look at our code, let's look at a web page which we're going to be displaying. I've opened this web page in Chrome, and we can see at the bottom of the web page we have a table. We have a title for the table, and we have a couple of columns and one data row. If we have a look at the source of this, we'll see here is our table construct, starting with a table tag, followed by a caption which contains the title of our table, followed by two rows of data. The first row is using the th tag. These are column headers. The second row is a data row using the td tag. So we're going to extend our code to support this construct. There is a great deal of functionality embedded in the table tags. However, today we're just going to start with the absolute basics. So let's have a look at our code. So the first thing we'll do in our code is look at the render HTML tags function. This is our rendering engine. Inside here we have a section which is a select case block. In here we have case statements for each of the different types of tag. So we're going to add table to the end of this list. As the table tag can contain many nested tags, we're going to operate within a function here. Once we reach the table tag, we're then going to read forward till the end of the table tag, and we're going to do all of that in a new function which we're going to call buildTable. This takes a single parameter, which is the start variable. This variable indicates where in the HTML we're actually reading. So this is the skeleton of our new function buildTable. I'm creating two local variables, one for data and one for lowercase data. The data variable is going to contain all the information between the beginning table tag and the end table tag. And the LC data variable will be the lowercase version of that. We'll be stepping through the data string one character at a time. So we'll need a variable to keep track of our character, and we'll need to know what our last command and our next command are for other nested ones in the future. So we're going to create a number of variables much along the same lines as we did in the previous function. These variables will allow us to keep track of where we are and to have a construct which is very similar to the previous function, the render engine. The approach I'm going to take within this function is to build up an array of data. This will be all the string data that's held within the table construct. As we don't know how wide each of the columns are to be within the table, we'll need to work that out. So we'll need to work out how many header columns we have, how many data columns, how many rows, and how many columns. So we're going to have to create some more variables. This should allow us to keep track of where we are when we're building up our table array. So our first task within this function is to get the actual data between the beginning table tag and the end table tag, and then populate the lowercase data variable with the lowercase version of that. So to do that, we can make use of the function we've created in previous videos, the getTagValue variable. This will return all the data we require between the beginning table tag and the end table tag non-exclusive. And we'll turn that into a lowercase version by using the $case command. Next, we'll need to work out how many rows and how many columns are held within that table. So we're going to populate three variables here: the header columns, should there be any th tags, and the data columns, should there be any td tags. And we can work out our row count by counting the number of tr tags. And PowerBasic has a command called tally, which can be used to count these very easily. So we're looking inside the lowercase data variable to look for the th tag, and the value returned will be stored in the header columns variable. And the same approach is taken for the data columns and the row count. It's always possible that some of the columns may not have headers, so we need to work out which is the largest of the header columns and the data columns, and we can use the max command to work that one out. And we'll populate that in our column count variable. So if the header columns is actually greater than 0 and the row count is greater than 2, then we'll need to work out the column count based on the number of rows, as the td tags will be multiplied for each row. So this will give us a true column count. Now we know the number of rows and number of columns, we can prepare our string array to hold the data that's held within the table. So we're dimensioning from 1 to the row count and from 1 to the column count in a two-dimensional array. So now we need to populate that array by stepping through our data variable one character at a time, just as we did in the render array. So we're picking up one character at a time and we're populating the command variable. So just as we did in the render function, we're actually testing the value of our char variable, and if it's an opening tag, then we're picking up the command. We're storing the last command, and we're moving on to work out what the end data is, and storing all of that in our command variable. This section of code is just cut and pasted from the previous function. And the next section will be to capture attributes. We're not in this video going to handle attributes of the th and td commands, or the tr command for that matter, but we need to be ready to do that in a later video. So we're going to capture the attributes. And this code is taken again straight from the previous function. We're storing the attributes in an attributes variable, and we're trimming them from the command. And we're setting two booleans, one for in command and one for exit command. We'll be making use of these in a later video. So if the character we picked up is an right angle bracket, then we're at the end of a tag. And now we can decide what to do with the data we've picked up. This is where we test the command variable. So the first subtag within the table tag we're going to look at is caption. Not all tables will have a caption tag, but in this case we're putting it in anyway because it is supposed to be supported. And in order to pick that up, we're going to use a function which is very similar to the getTagValue function we created in previous videos. But we're going to call this one getTableTagValue. And it's going to take 4 parameters. The character position we're at, in this case the t variable, the end tag we're looking for, in this case the end of the caption tag, the data containing the data inside the table, and the lowercase data version of that. So we will create that new function and we'll come back to this function in a moment. Here is the existing getTagValue function. This returns the content of a tag. And here is our new function, which is very similar. getTableTagValue, taking the 4 parameters we have just specified. It looks for the start position, the ending position, and returns the data in our midstring command. So now that we've created the getTableTagValue function, let's now add support for other tags within the table tag construct. We'll need to put something in that handles the tr tag and the closing tr tag. These indicate the beginning and the end of a row. For the tr tag, which is the beginning of a row, we're incrementing our row number. And for the ending of the row, we're setting the column back to 0. So we have two other types of tag to support: the header columns and the data columns. So for the start of a header column, we will increment the column number. And our next task is to get the data for that column. And we're going to reuse our getTableTagValue function here to populate our column data variable. This will give us the information that we need to insert into the array. So now that we have that data, we can insert it quite easily in our table array by using the row and the column elements. And we'll set our header flag to true to indicate that we're inside a header. So we're going to have to do exactly the same in the TD tag, where we have data. We have to increment the column and populate the table array. At the moment, we don't have to do anything at the end of a header column, but we do have to do it for the TD tag. So we're doing exactly the same for that, incrementing the column number, getting the data, and storing it in the table array. So by the end of this for next loop, we will have gathered all the information that needs to go in to the table. So our next task would be to display this table information onto the graphics control so the user can actually see it. So we'll create a separate function whose job it is to display the table. And we'll call that new function displayTable, taking 3 parameters. The first being a pointer to the table array, followed by the value of the caption variable, and then followed by the header. The header flag is used to tell this function that there is indeed a header in the data. It's quite possible that some tables will not have headers. So we now have to create this new displayTable function. So here is the header of our new displayTable function, with the 3 parameters we have specified. As we enter this new function, we have at the moment no idea how big the table is going to be on the graphics control. This will depend entirely on the data held within our array. So we're going to work out the width and height of the character based on the font we're using. We're going to work out the width of the caption, the width of the entire table, the number of columns in the table, and we'll need an offset to position the caption. Captions are generally justified in the center of the table. And we're going to step through our array using a column and a row variable. So we're going to work out the number of columns in the array by using the ubound command on the table array. Since this is a 2-dimensional array, we're looking for the second dimension. This tells us how many columns there are. We can then prepare a new long table columns array. This will contain the number of elements matching the number of columns. This is going to store how wide each column actually is. This is so we can display them to the user without them overwriting each other. So we're going to use the graphics cell size command again. This works out how wide and how high our single character will be based on the font we're currently using. Next, we're going to call a new function to work out the width of the table. The width of the table will be based on how many characters are in each column, and we'll need a small spacing buffer between each column so that the characters don't run into each other. So we're passing to this new function 4 variables: the table data itself, the width and height of a standard character, and what we're expecting back is a populated long table columns array containing the width of each column. So we will create this new function in a moment, but let's push on with the logic within this function. We next have to test to see whether we have a caption or not. If the caption string is 0 length, then there is no caption. So this section of the code is entirely devoted to captions. If we have a caption, then we will work out the caption width based on the standard width of a character. We will multiply that by the number of characters in the caption string. If the caption width is less than the table width, then that means it's smaller than the table, and we can then calculate our offset, adjust our global positioning of where we're going to print to next by that offset, and then we're going to set that position, print out our caption, and then get our current position at that point in time. So this should handle printing captions where captions exist. Now that we've determined the width of each column, we can now print the data to the graphics control. And again, this is going to be a for next loop. First, we will determine the current printing position on the global X and Y coordinates. And then we're going to step through each record, each row within the table array. So if we're on row 1 and the header variable is true, then we know that the first row in our table is a header row. Our browser would print these header rows in bold. So we're going to set the font to bold font. We have an array of fonts already set up which are bold. So the fifth font is going to be the standard one we're going to use. So we'll create the bold font value at the beginning of our code. So this is going to be 12-point bold. So within the for next loop for the row, we'll need to do a for next loop nested for our columns. So we will first set the coordinates for X and Y on our graphics control, and then we're going to test to see if we're on column 1. If we are on column 1, we're going to put some padding before the first column, so that the table does not appear right at the left-hand edge of our graphics control. So we're going to add on 1 character width to the X coordinate, and we're going to set the position there. For the remainder of the columns, we'll need to work out what the previous column's width was, and we're going to need a new function to do that. We'll call that getPreviousColumnsWidth, and we'll pass that a couple of parameters, one for the table columns array, and one for the column we're currently working on. We'll double back and create this new function in a moment. And once we've done that, we will set the new position to be our X and Y coordinates. So now that we've set the position for where the column is to begin, we can then print out from our table array the actual data held within it based on the row and the column elements. And at the end of our graphics print statement is a semicolon, which will tell PowerBasic not to go on to the next line, because we may have more columns to actually print. So once we get to the last column in a row, we then have to test for the row and the header being true or false. If this is a header, then we want to reset the font to normal using our global handle for the default font. And then to finish up, we're using a graphics print command to ensure we go on to the next line and then pick up the next X and Y coordinate. So now that we've finished the function to display our table onto our graphics control, we have a couple of functions we have referred to which we still have to create. One for the getPreviousColumnsWidth and one for the width of the table. So let's do the previous column's width first. This one is going to be a fairly straightforward function. It's taking in the 2 parameters we specified, the array of table columns and the column we're currently on. And this one is going through a simple for next loop, from the first column to the column before the one we're currently on. And it's adding up the width of each of these table columns. So this will tell us where the column should now begin. So our final function is the width of table function. This is the one that works out the width of a table for each of the columns. And again, we will need some local variables to keep track of the column, the number of columns, the row, the number of rows, and the total width we're going to return to the calling function. First of all, we will pick up the number of columns and the number of rows based on the array we've been passed. Next, we're going to have to do a nested for next loop, looking through each column and each row. This function makes good use of the max command to work out which is actually larger, the column in the current row or the column in the previous row. And then in the table columns array, we're also going to be adding 2 extra character spaces. This will allow us more room. so that the data in one column does not run into the data in the next column. So now that we have this final function finished, let's try and compile to make sure we haven't missed anything. So our application compiles cleanly, so let's try running it and see what we get. So we have our browser on screen. Let's just drag in some data from one of the HTML pages. And there we have on screen our table at the bottom of the page. We have the caption, we have the title columns, column 1, column 2, and we have the data underneath it. Let's try it with another page with some more data. Now we have another page which has one header and two data lines. And again, we can see our caption is actually positioned in the middle of the table, and we have data 1, data 2, a larger data column, and a smaller data column. So in summary, what we've achieved today is we have added support for table tags. Within the table tag, we're supporting the caption tag, which allows us to put a caption above the table. We have support for the th tag to allow us to put column headers in, which are shown in bold. The width of the column is driven by the data within that table. If the column header is wider, then that is the width of that column. If the data tag is actually wider, then that will be the width. So this is the very basics of the beginnings of table support. There is a great deal more in attributes you can do with tables. However, we will leave that for a later video. That's it for today. Thank you for watching.